In this lecture, we start chemical engineering mathematics, second order Runge-Kutta method, simultaneous differential equation. Let us see the example of second order Runge-Kutta method. Problem is solve the equation dy by dx which is equal to x plus yz and dz upon dx which is equal to x square minus y square using Runge-Kutta method under the boundary conditions x is equal to 0, y is equal to 1 and z is equal to 0.5. Find y and z and x is equal to 0.2, h is equal to 0.2. Now we see the solution of that second order Runge-Kutta method. Right here given data dy by dx which is equal to f of x y z which is equal to x plus yz and dz upon dx which is equal to g into x y z which is equal to x square minus y square. Here given three variables, that is x, y and z. Now the initial value is given, that is x0 is equal to 0, y0 is equal to 1, z0 is equal to 0.5 and xg given is 0.2, h is equal to 0.2. Now required value of yg, zg and xg is equal to 0.2. We calculate yg and zg for 0.2. Step 1. Calculate the value of k. Calculate the value of k. 1. F of x0, y0 and z0 which is equal to x plus yz which is equal to 0 plus 1 into 0.5 which is equal to 0.5. K1 is equal to h into f of x0, y0, z0 which is equal to x plus yz, that is 0.2 into 0.5. Answer is 0.1. Now g is x0, y0, z0 x square minus y square which is equal to 0 square minus 1 square which is equal to minus 1. Now we calculate L1, that is h into g x0, y0, z0 which is equal to 0.2 into minus 1. Answer is minus 0.2. Now we calculate f of x0 plus h, y0 plus k1 and z0 plus L1 which is equal to x plus yz. 0 plus 0.2 plus 1 plus 0.1 into 0.5 minus 0.2 bracket complete which is equal to 0.53. Now we calculate K2. K2 which is equal to h into f of x0 plus h, y0 plus k1 and z0 plus L1 which is equal to 0.2 into 0.53 which is equal to 0.106. G in bracket x0 plus h, y0 plus k1, z0 plus L1 bracket complete which is equal to 0.2 bracket square minus 1 plus 0.1 bracket square which is equal to minus 1.17. Now we calculate HL1 which is equal to h into g of x0 plus h, y0 plus k1 and z0 plus L1 which is equal to 0.2 into minus 1.17 which is equal to minus 0.234. Now we calculate final k. formula for that, k1 plus k2 divided by 2. Also, we find already k1 and k2. Value of k1 is 0.1 and value of k2 is 0.106. Now, k is equal to 0.1 plus 0.106 divided by 2, which is equal to 0.103. Now we calculate L1 plus L2 divided by 2. L1 is minus 0.2 and L2 is 0.234. Now put in the formula minus 0.2 minus 0.23 divided by 2. We got answer minus 0.217. Last step, we calculate Yg and Zg. Formula for that, calculate the value of Y and Z. Yg which is equal to Y0 plus K. Y0 is 1 and K is 0.103. We got answer Yg, that is Yg which is equal to 1.103. Now we calculate Zg which is equal to Z0 plus L. Value of Z0 is 0.5 and L is minus 0.217. Then Zg which is equal to 0.5 plus in bracket minus 0.217 bracket complete, Zg which is equal to 0.283. At the value of xg is given, that is x is equal to 0.2, yg is equal to 1.103 and zg is equal to 0.283. This is the final answer. Now we see the second order Runge-Kutta method, second problem. Similarly of that, the relation between x and y is given by dy by dx which is equal to x y which is equal to 2. Estimate y at x is equal to 5.1 using the second order Runge-Kutta method. Assume y is equal to 2 at x is equal to 5. Take a step size of 0.02. The given data f of xy is equal to 2 minus xy, x0 is equal to 5, y0 is equal to 2, h is equal to 0.02 and xg is equal to 5.1. Required value of yg at xg is equal to 5.1. Now we calculate step 1. In the step 1, calculate the number of steps. N is equal to xg minus x0 divided by h. In the given problem, xg is given, x0 is given and h also given. The value of xg is 5.1 minus x0 is 5 and h is 0.02. We calculate n is equal to 5. Now the first iteration, that is x0 is equal to 5, y0 is equal to 2, x1 is equal to x0 plus h. x0 is 5 and h is 0.02. We calculate x1, 5 plus 0.02, answer is 5.02. f of xy which is equal to 2 minus xy. Step 1. In the step 1, calculate the value of k. dy by dx 2 minus xy dy by dx which is equal to f of x0 y0 which is equal to 2 minus xy, 2 minus 5 into 2 which is equal to minus 8. k1 which is equal to h into f of in bracket x0 y0 bracket complete, which is equal to 0.02 in bracket 2 minus xy bracket complete, which is equal to 0.02 into minus 8. We got answer minus 0.16. f of x0 plus h y0 plus k1, which is equal to 2 minus xy, which is equal to 2 minus 5 plus 0.02 into 2 minus 0.16, which is equal to minus 7.2368. We calculate the value of K2. K2, which is equal to h into f of in bracket x0 plus h y0 plus k1 bracket complete, which is equal to 0.02 into minus 7.2368, which is equal to minus 0.1447. Next, we find the value of k. K1 plus K2 divided by 2. Value of K1 minus 0.16 and value of K2 is minus 0.1447 divided by 2, which is equal to minus 0.1523. Step 2. Calculate the value of yg. Yg is equal to y0 plus k. Value of y0 is 2 and value of k is 0.1523. Then yg is equal to 2 minus 0.1523, which is equal to 1.8477. Similarly, we calculate the iteration 2. In the iteration 2, value of y0 we take 1.8477, x0 is 5.02 and value of y0 is given, that is 1.8477. Then xg is equal to x0 plus h, 5.02 plus 0.02. Then xg is equal to 5.04. Similarly, we take same step. We calculate first k1 and k2. Then f of x0 y0 2 minus xy, that is 2 minus 5.02 into 1.8477, which is equal to minus 7.2754. K1, value of K1, that is h into f of x0 y0, which is equal to 0.02 into minus 7.2754, which is equal to minus 0.1455. Similarly, we calculate f of x0 plus h y0 plus k1 2 minus xy, which is equal to 2 minus 5.02 plus 0.02 into 1.8477 minus 0.1455, which is equal to minus 6.579. We find the value of k2, which is equal to h into f of x0 plus h y0 plus k1, which is equal to 0.02 into minus 6.579, which is equal to minus 0.1315. We calculate k. K1 plus K2 divided by 2. We got answer minus 0.1385. Similarly, we calculate yg, that is y0 plus k. Answer is 1.7092. Similarly, we take iteration 3rd and iteration 4 up to the iteration 5. Then we take table iteration 1, 2, 3, 4 and 5. Value of xg, k1, k2, k and yg. Now, after iteration number 5, the value of yg at xg is equal to 5.1 is 1.36 phi 1.